we don't know exactly what he wants out of the suit, except for OpenAI maybe to become open. I don't think that's going to have an impact on Figure moving forward, that they're going to still get access to the compute. They'll be able to do it, because that was sort of the missing piece from them, is like, well, they got a small team, but where's the compute? The other thing is to remember is that the investment that came into Figure, and will probably be coming into some of these other companies, is coming from big players. These are companies that know how to do due diligence. So they just don't throw out $100 million investment here and there just because it's, it's their gambling money for the week or something like that. They never want to be looked as a sucker. They want to make sure that when they do it correctly. They have a fiduciary responsibility to shareholders and everything. So you can bet they looked at it, a lot of the others looked at it, and to see those names kind of going in there in many cases sort of says that, yeah, they're confident that the humanoid bots are coming, and they're pretty confident that Figure would be one of those strong players. But I think overall, it means there's like just an endorsement of the humanoid bot field. That's the biggest takeaway I took from that Figure closing, was that it's showing that, and I've used this before, if no one's heard it, it's basically paraphrasing the great Arthur C. Clarke. And that is, the human bots will come 5 years after everyone stops laughing. And as we know, till now, there's been a lot of laughter about it. But once that stops and everyone gets research, and if you remember Arthur C. Clarke, that was a quote he made about the space elevator. But in that case, it was like 50 years after the laugh. And the laughter still hasn't died down. So I think we're still at least 50 years away from the space elevator. But again, it's that idea that you could have an absolutely fundamentally a breakthrough technology. And if there's a stigma, people refuse to do it because they're kind of afraid of getting laughed at. And now that people are taking it seriously, the money starts moving in there. The R&D starts happening. Other countries start taking notice. So it's going to be an exciting future.
For someone listening to you for first time, how would like to define yourself? Yeah.
Well, I guess, I'm just someone who's always liked science and engineering since I was a kid. I grew up in the let's say, during the time of the Apollo space program. So I just love following, space and everything else. And that's what I wanted to do. So I went and got an engineering degree and then an aerospace degree. But along the way, I got a little bit diverted because when I did my doctorate, it was more in the area of computer graphics and how it could be applied to mechanical systems and understanding how those systems would work. And right around that time, so this is the mid 1980s, industrial robots were starting to really invade the American shores to come in and start being used in manufacturing. And they needed these tools to be able to help them plan and understand what they're doing. So I kind of changed from being more of an aerospace engineer to going into robotics and looking at how do you simulate these systems, how to make it easier for people to program it so they could create factories with full-scale automation. And that's what I've been doing. Along the way, I got kind of lucky that every now and then one of our customers would be an aerospace company, including NASA every now and then. So back in the late 80s, we did some simulations of the Canadian arm that was in the back of the shuttle, and did simulations of payload retrievals, including the Hubble Space Telescope. So I still was able to scratch that itch of getting a little bit of, the aerospace in there and understanding that. But like I say, my focus has sort of stayed there on robotics and the traditional kind. So I like to joke when I've done, some presentations in kids' schools and in other seminars, that when I tell everyone that, I'm working in the field of robotics, they imagine this. And the picture I'm showing them is like C-3PO, Robbie the robot, R2-D2, because that's what everyone thinks a robot is. And they show them what the real robots are. And it's like, it's these boring industrial arms. But now the tables have turned. Now, when you start talking about that, if you're working in the field of robotics, you could be talking about something that actually does look like C-3PO. And that's what's captivated me is in the past, I guess it's about 2 years, is as soon as Tesla sort of announced they were doing that, it was like, oh, finally, that moment is here. Because I knew it was coming. I knew it because you had companies out there that were trying to solve the problem of a humanoid bot. And it's challenging because it's not as easy as just doing a simple arm. And a lot of it is a mechanical challenge, but the big thing is the brain. And it couldn't be accomplished before because we didn't have the AI technology that would really be able to make it work the way we want. And then now, as you see, it wasn't just Tesla announcing that they were going to build a bot. There were other companies that were already doing it before Tesla. It's just that we weren't aware of them. And there are companies since then. And now it's heating up. It's like at least once a week, if not almost every day, there is another company in China that makes an announcement that they're working on a humanoid bot. So we're going to be seeing that. And it's not just like the US and China. A lot of other countries are getting involved. You just don't know about it behind the scenes. So I think it's kind of a worldwide effort. There's a lot of interest going in that space. And, I'm kind of an observer at this point, but hopefully I can help your audience sort of understand what's going on, what's the importance, what the challenges are, what the potential is, and, what are the potential downsides that we have to be kind of concerned of to make sure we navigate those waters correctly, because I really believe it's going to be an overall net benefit, but there's possible downsides if we're not aware of what those could be.
Mm-hmm. Maybe I want to go, what makes humanoid robots, especially in the last 2 years, just becoming a hot topic? That's a question about a community. This already exists for many years ago, 20 years ago, but now it's just resurfacing again, and there is a competition. What caused this in the beginning? Can you tell me like the beginning of it? Just let's invest in the humanoid robot again.
Yeah, I think if you go way back, you go back to some of the science fiction writings of Isaac Asimov and others that kind of put the seed in people's heads, the idea that you could have these mechanisms that were very human-like. I mean, you can even go way back further than that. Basically the clockmakers of the 19th century were making these automatons that, were mechanical people that would kind of move around based on clock mechanisms that at that time people thought they were real, so they're just mannequins that were able to do these things, but they weren't very programmable and they weren't very practical. And of course you see them in Disney World rides and all the time. So that's been there. It's just never been really, well, can we do something more practical than something that's just kind of good entertainment, but really can walk around, do everything. And of course, science fiction has constantly portrayed them. We keep on seeing them, that they're in there, but why don't we have them in our daily lives yet? And that is that technology was not mature enough to do it. So the very early days of it is you have Honda with their Asimov project, which basically was a hat tip to Isaac Asimov. We're working on the problem of being able to bipedalism, being able to get a mechanism to work. And the really early ones, if you look at some of the YouTube videos of what they were doing over 30 years ago, I mean, these were just like big legged things. And they had like this huge platform that the legs had to carry. And that platform was like the compute. And it was like the computers, they had laptops on there really heavy. It's like, oh my goodness. I mean, so there was no upper torso or anything. They're just trying to figure out how to go upstairs. And they had to have all these cables and stuff to provide the power to do it, because they were trying to solve the problem of being able to walk without falling over using what was like really antiquated kind of computing equipment. So that's matured, it got better. And, eventually they were able to make a full humanoid bot. But unfortunately, in 2017, they kind of gave up. And it's because they couldn't really find a use for it. It was kind of this party trick. It was really neat that they could do all these things, but it was like, okay, is of any value? And they may have given up a bit early. And I would hope they would resurrect the whole thing, because what was missing was the brain, was the AI compute. And you've been following a lot of technology, so you're probably aware of Tony Seba and the way he talks about technology and S-curves and everything. And he drives home this point. It's like, there is a reason why the iPhone was invented in 2008, not in 2007 and not in 2009, because it was a convergence of technologies that allowed all those things to happen together. It was inevitable. If Apple didn't invent the smartphone, someone else would have. And other people argue, well, some people maybe kind of did, but it was all around that time. There's a reason it wasn't in 1995. It wasn't there. So now you're starting to see the emergence. And of course, the glimpse that Tesla saw is that by trying to solve full self-driving, they were coming up with what they basically call robots on wheels. So it's something that has to understand how to navigate the world. And they began to believe, boy, we've got an inference engine here that maybe could be used for something other than that. And other people have thought about that as well. I mean, you can, there are a lot of others that were seeing that when Waymo and others were getting into this field already back in 2013, they were saying, you know what? If they solve that, they possibly could do like humanoid bots. The intelligence might be there. And so that's been one thing. And what's going to be nice is that once they solve what the neural net is going to be like, they already have the chipsets they need, because, NVIDIA and Tesla and all, they're already producing this stuff. So it's not like what's going to hold off the production of the humanoid bots is going to be the compute. It turns out you can buy it. The problem is we don't have the neural network yet, the stuff in there that will actually do the job that we want, but we're getting closer and closer as LLMs get better, all those things. As far as battery technology, don't worry about it. It's being scaled in other places. You just be able to buy this stuff off the shelf. So there's all these other components that you can get off the shelf right now that will allow you to assemble it. And you are seeing companies like really quickly being able to pull something. In some cases, not all with off the shelf, because Tesla has mentioned the actuators. And, for those in the audience, an actuator is basically like a really fancy word for a motor. So it's something that will cause something to move, but it's got a little bit more than a motor in it. It usually has like some encoders and some control logic in there to be able to make sure that it's able to do it the way you want. So you give it a commanded position, it'll move there. So you need those for the robot. And you can buy actuators all over the place. There are catalogs with them. The thing is, they're designed for the wrong purposes. It's like cars have got actuators in there, and some of the, to make the windows go up and down and the hoods and stuff like that. And some of those are like wrong form factor or too powerful or too weak for what we need. And then obviously, if you look at the motor drives that are an electric vehicle, that's way more power than you need in your robot. So you need to redesign those things to kind of fit your requirements. And so a lot of them are finding that we can get some stuff off the shelf, but it doesn't make a really good, compelling humanoid bot that has all the characteristics we need. It's going to be too heavy and it's going to consume way too much power. And we need to design these to be more compact to be able to provide that. So that is really where a lot of the development work has been going, is that what should the actuators look like? Then there's the other is like the kinematic kind of structure that you want to have. So you want to have something that looks like a human being. And it's very easy to build a skeleton. I get this thing here. This it's like really easy to build a human skeleton. Anyone can do that. And this is, kind of faithful to what it's doing. It's got a few things here that aren't exactly the way the human body works, but it's close enough. Now, the trick is, how do you put the motors in there to make this do that? Okay. That's where it gets a little bit harder, is figuring out what they're going to be. And there's many, many different approaches, and they're all they're trying to find what is the best approach. And some of them are trying to put, 3 different motors in the shoulders, because our shoulder can actually rotate in 3 different directions, and trying to figure out how to put them together. And they'll be using what they call rotary actuators, so that, if you want to rotate about the shoulder this way, you get a motor that just goes back like that, and then you get a different one that will make sure you can do this. And you've got to put them together in such a way that you can run the cables through without the cables getting all twisted up, make sure it's not too heavy, and also have kind of a faithful movement to it. Well, others are thinking, oh, wait a minute, that's not exactly how our shoulders are built. It's like we don't have 3 different motors in there. We've got a ball and socket joint. Yet, if you look out there, all the robots that are out there, the humanoid bots, they don't have a ball and socket joint. Now, a ball and socket joint is almost as easy as a hinge joint. So your elbow is a hinge joint. And if you don't know what a hinge joint is, just look around your house. All right. It's like your door has got a hinge on it. And sometimes it's called like a pin joint or something like that. So basically you get these 2 mechanisms to come together, and you put a cylindrical pin through it, and it just allows everything to rotate about it. That's a fairly easy thing to do. But the funny thing is, even though we represent our elbow as a hinge joint, the human elbow is not actually a hinge joint. It's like these 2 things that kind of rub together, that are held together by all these tendons and muscles that you can approximate pretty well with a hinge joint. But when it comes up to the shoulder, our shoulders are actually a ball and socket joint. And you get examples of ball and socket joints around your house if you've got like a camera tripod. I mean, that's the perfect example. It's a really easy mechanism to build. It's a really hard mechanism to actuate, to get it to move. It's like, yeah, you can get your hands and grab it and move around where yours and tie it down. But if you're actually trying to actuate, it gets to be a bit challenging. So a lot of them give up on that, and they decide, oh, we'll just use rotary actuators. But there are others that are saying, hey, let's see. And it's Actuator, which is another company. They're doing everything with what they call linear actuators. Okay. So rather than having a motor that kind of spins, you have a motor that when you turn it on, just makes things kind of go in and out. So they extend. And, kind of an analog, if you look at like the screen door in a house, and I know it's going to vary around the world. I'm just thinking like an American house, others are a little bit different, but you have a screen door and it's got this damper on it that helps the mechanism close. And it's like a piston cylinder there. Okay. That thing's there to slow down the movement of the closing of the door. But imagine, rather than slowing it down, if you actually put a motor in there that would extend that would push it out, it would cause the door hinge to open out and to close back in there. And that's the kind of mechanisms they're thinking. And Tesla's actually got a mechanism like that in the elbow. And some of the other robot companies do, and some of them don't. Some did a direct rotary actuator there. And others are thinking like, well, how do we put these little linear actuators on the shoulder to make it move? And that would be one way possibly of doing it. Now, if we go back to science fiction and you look at C-3PO, you will see C-3PO has what looks like these little piston cylinders coming out on his elbow and up here because, Lucas and others were trying to imagine, okay, how would a mechanical man work like that? How would the actuation done? Because we know when you open up C-3PO is like tons and tons of wires in there and stuff like that, just because the Hollywood producers said, that'll look cool. Just tons of wires in there. We don't know what they do, but it looks great. But they were thinking, everyone's going to wonder how it moves. And you'll see also in his head, like these little things that are on there that kind of like, are going to stick up and move. And so you're already imagining that. And they're not far off of that would be a potential way of actuating some of these things. So again, I'm rambling. I'm going off here. So
no, this is one of the points I wanted to focus on about Actuator. And I think you already have discussion with Brad Adcock, the CEO figure, about the custom actuator they design, and also for Tesla. So we want to deep dive in that and what actually they did. And since you mentioned each company in the competition, they have different technique. One use linear actuator and the other use rotary actuator. And there's nuances here about the design. And I'm curious from the interview also, you interview a couple of these companies. Also, you have already a company, Humanoid, just to give solution. I think recently you founded.
Yes. So along with Herbert John and Cern Basher, we formed sort of two companies. One's a nonprofit, which is called Humankind. And the idea of that is to kind of get, people who are thinking about what's coming and what are going to be the safeguards and standards and how do we kind of prepare, humanity for the fact that human bots are going to be a thing. And how do we cooperate with them and how do we get people to understand that? And we want this to be like all encompassing. We want people from around the world. We want, people who are really thinkers about this to sort of get involved to give the discussion of what is it we expect of these things? What are going to be the rules and regulations that kind of guide some of these things? What do we do to help potential job displacements, which I think is not going to be a problem in the near term, will be more of a long-term problem. So we can get into that a little bit later. And then the other one, which is a commercial one, is like there's a lot of companies out there that are saying, wow, these humanoid bots are coming. How do I prepare for it? And they may not know. And so we will go in and help them understand what the capabilities of these bots are, where they can potentially use them and not use them, where they would make sense, and do a business plan so they understand that, hey, this is either going to save you money or it's not going to save you money. And so that's part of what we're doing to help people make the transition in both aspects. One is like commercially, how do I do it to stay competitive? And the second is that should I be afraid of these bots or are they more going to be an opportunity?
Before going again to Actuator, because I think that's a very interesting topic to be discussed in detail, but the first thing is in the robotic community, when we have this announcement, especially for Figure AI and the investment and evaluation they had, there was a debate inside the robotic community. There's a question. One of them, why humanoid robots? Just some of them just say that it doesn't make sense to have the biomimicry side. It is not the optimal solution. And one of the arguments just was that, like, for Ford, for example, when they envisioned about faster vehicles, they didn't say, let's have a mechanical horse, for example. That's one of article within a Medium. So they envision faster wheels, for example. It's just, the point is you don't have to do the exact same thing as a human. You see what I mean? That's one of the arguments. Why we have to do the same thing. Another thing is that the AI thing is not there, the brain side. Yeah, there is counter argument. It's just a knowledge thing. It's not intelligence itself or not generic intelligence. And the other aspect about the mechanical side, just hardware, we're still not there yet. And I think that's where we cover. Can you tell me how do you think about, firstly, why humanoid robot? And some people's robotic community figure against the idea that it doesn't make sense. It's not the right solution. Let's say it's not the right solution.
Okay, and I think when it comes to the argument everyone's making, it's like everyone's right and everyone's wrong. Okay, you can make a point in isolation where you are absolutely correct, and then in others you're not. So when you talk to everyone that's out there, like, why bipedalism, why a humanoid bot, why two arms, and everything else, the main argument comes down to this: is because the world has been designed by humans for humans. So the size of everything, the way things function are designed around our form. And in order to sort of operate in that, it's it's really useful to have the same thing. So our tools are designed for our hands. They're designed for five-fingered hands. A lot of operations we try it. I mean, sometimes it feels like you need to have a third arm, but usually we try to design things that you can do it with two hands. Our door handles are designed in a particular way for our mechanisms and everything else. And so if you want to operate in the human environment without changing anything, then you need to make sure something that's kind of compatible for it. So that's the first thing. The other is that when you start having these mechanical things, we can relate a bit more if they're kind of humanoid in form rather than something that's maybe a bit odd or scary. So it might be that, some sort of arachnid form is like the ideal form and it seems that if you look at nature, all the bugs that are out there, they seem to be pretty efficient at what they're doing. But that's going to be kind of scary and creepy, and people are not going to necessarily like that. So, if you're going to have a robot come with you somewhere in the car, it has to kind of be able to sit in the seat. And if it's an arachnid or something like that, it might not get in there very easily. So that'd be one thing. But, also just operating in your space. The other thing is to realize the idea of the humanoid bot is not to be superhuman. The idea of it is to be able to do the same things that a human could do. And to be, and the things that humans are very good at is being generalist. We're very good at being able to do lots of things. If you start making something which is superhuman, suddenly you become more of a specific operation, and you may not be able to do other things. So that's part of the idea is that yeah, we can make them do these great things, but as soon as we do that, we may limit it from being able to do something else. So if we make it like really tall, well, it's not going to fit in the house. Okay, it's great in the shop floor. This big burly thing is lifting up car bodies and throwing them on over there once to. It's like, but I'm not inviting that thing home. It's just I want something that's going to be more human scale. So that's part of the reason. Now, it doesn't mean that they won't change, because there's argument. 2 legs or wheels. What's going to be better? Depends upon the environment. There's going to be these environments for the humanoid bots, depending upon what they're doing, where basically a wheeled base may be the better choice. You go ahead and do it because it's in the structured environment where everything works. Others where it's like, it's really rough to get around, you need to have that. And if you need one that has to operate in both, you got to have legs. I mean, that's the only solution. It may not be ideal when it's a super flat surface. You might say, well, and then you'll have these others where the idea is like, well, what about if we change to a special tool? It's like, oh, okay. So you go swap out the hand, you can put something on it. Great. Well, I want this bot to come in. I want it to work in my kitchen. Okay. I also want to be able to work in my kitchen. I don't want to have 2 blenders. I don't want to have the bot blender that only the bot can use and sticks on there and then does everything. And then if I want to do it, I got to go dig another one. No, the idea is the bot's going to use the utensils I have in my kitchen, and I don't want to redesign my kitchen around the bot. So I don't know if that's that's like a medium answer. The answer can get very long, but hopefully you sort of see the trend line that's going there is that we will have specific bots eventually for those tasks once we've solved the bigger problem. And we already do that. You go into a factory, you will see robot arms in there that are really good at what they're doing, welding, pick and place. But you'll notice they're stuck to the floor and they can only do that one task. They're really good at that. You ask it to do something else. Nope, it can't. And we redesigned the factory around them and to sometimes our detriment. So originally, an automobile factory had a lot of spot welding lines and it was all done by human operators. Usually big burly guys because you had to have these big spot welding guns you moved around, and they'd be suspended by cables from the air because they were kind of heavy to bring around, and they knew they had to hit like 8 or 10 spots roughly in some area, and they go click 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 click, and then the next car would come in and do that. Now, then the bots came in to replace them, and now these bots can't walk around. They're big arms. I mean, they're not the size of a human arm. They're like the size of a whole human body, and even taller than that, to be able to grab the spot welding gun and move it around. Now, they didn't take the spot welding gun that the humans were using. They redesigned the spot welding guns to get mounted on the end of the robot arm, because when you buy an industrial robot arm, surprise, surprise, it doesn't come with a hand. It doesn't come with a gripper or anything like that. It comes with just a mounting plate, a flat mounting plate that you stick your end of arm tooling on with bolts. So that's how it grabs onto the spot welding gun. Well, wait a minute. The spot welding guns the humans are using had like a human interface, didn't they? So suddenly what that means is your tooling has changed, and that once you put those bots in, and the bots were bolted to the floor as well, that if a bot went down and you expected a human to go in there and take the tool off the robot and start doing it, it was not going to happen. And the other thing is the bot's still in the way. It's like, get them out of the way. I need to get in here. So you would have to go in with different tooling. So that's sort of what ends up happening, is that once you decide to make them very specific, now you lose the ability of being able to swap it in and out. And what we'd like to do is, not have to redesign the workspace.
I see the point. I think this is one of the points. Do you think there's other extreme points, like especially when people argue against humanoid robots? This is one of explanation, but do you think there's something extreme argument that you think of in that case, or against humanoid robots?
That's one of them, and there will be other form factors. I mean, we've already seen that Boston Dynamics has what is a dog. And not only them, it's like a lot of Chinese companies. Also, the ETH in Zurich has got very interesting rescue dog that they call Animal, or kind of like Animal, and they're the right form factors for certain things. And partly is like we designed our world, yes, for humans, but also for our pets. So in many cases it would not it would make sense to maybe have these other form factors that are going to be useful for other things. So that's why I'm saying everyone's right and everyone's wrong. It's just like, there is a place for the humanoid bot, and there's also a place for the robot bot, dog bot, and they're all going to be there. It just have to decide the use case and the economies of scale. So the thing about the humanoid bot is, because it's going to be so general purpose, it can keep on doing different tasks, and that's its utility. It's not that it's basically a jack of all trades, master of none kind of thing. And so sometimes it's useful to have a handyman that can do all these things. But, there's going to be the time where I don't want the handyman working on my roof. I want the roofer on my roof, because he really knows what's going on. But if it's just something that has to get patched up there, it'll be something like that. So I think that's really where it comes down to. There is no right or wrong answer, and we shouldn't exclude them. But if you start looking at caregiving and a lot of other things, people are going to want something which has this human element to it. But some might argue maybe you don't, because the more it looks human, some people are maybe even more scared of it, as opposed to like what looks like a cute little robot that's going around that isn't even trying to be human.
Maybe one of the questions, since you mentioned about the humanoid robotic, I think more than 12 companies. I'm not sure how many companies were competing in the space, but it's a lot.
Okay, I don't know what the actual count is, but right now we've counted like 21 that we've put on our list. We know there's more out there, but there's like 21 that we've gone and put on there. And this is a list that CERN Basher is he's compiling this list, and every time something comes up. And what's sort of nice about where it's been is that we don't have to work very hard to find these, because usually our followers will stumble across one and like send it to me and say, hey, guess what? Did you see this? And then sometimes it's like, oh yeah, I just saw it. Or like, whoa, thanks. I wasn't aware of that one. And you go in and you look at that, and many of them are coming out of China now. I mean, they're just, it's unbelievable, because the initiative that China has come up, they set a goal that, that by 2025, they really want to be pushing ahead, and then they want to be in a leadership position by 2027. And given the number of companies they have out there working on it, they're well positioned to really be able to, come up with bots. And believe it or not, they already are. So there's a couple of companies out there that are already producing them, not fully at scale, but they're starting to ramp up, that they're producing dozens, close to 100 per year. And one of them is Unitree, which I think last week they talked about how they get the world record for walking, and they showed that. And I'll just kind of clarify what that's meant, is that it's sort of the world record for a full humanoid bot. And I'm not sure if it's officially by Guinness, but believe me, the speed and everything I was saying there, it's like, it probably is. There are faster bipedal mechanisms, but they were without a full torso or anything like that. But it's getting close. And the speed that they have, I think they said, is like over 7 miles per hour, which is about 10 kilometers per hour, I think, something like that, 10, 11 kilometers per hour, which is way beyond what you need for working in the factory. It's probably 3 times faster than you actually need, believe it or not. So it's a pretty good speed. So that means they can do that. And if you thought it's like, oh, okay, that's just something that they're showing off. Well, they're selling it to research institutes. And there was a post 2 or 3 days ago in the University of San Diego of it walking around the park at the University of San Diego. And then, I don't know if you noticed that Carnegie Mellon put something out yesterday of what they're doing. They're learning to teach the bots just with video. So what they're having is that usually you do teleoperation, right? Like you have hand controllers, isn't like that, the way you control an avatar in a video game. And they've been doing that same thing with the bots, that if I suit myself up and if I move my arm like this, then the bot will move its arm like this. They're getting rid of all that. And they're just like, they're videotaping the movement of people. And from that real time, getting the robot to do the same thing, you know, lift its legs, do a punch, pick up a box and move. And they were demonstrating. This is just a bunch of grad students at Carnegie Mellon. And of course, so what they're working on is the motion capture end of it and trying to work out the AI, but they need a robot chassis to be able to do it. Well, guess which robot chassis they're using? The H1 robot from Unitary, just like, you know, University of San Diego is. So that's at least 2 examples I'm aware of in the continental US. And I'm sure there's probably a couple others are doing it, because a lot of them are doing the research on the fundamental area of how do we solve the learning, walking, all that problem. But we don't have time to build a bot. So there's one available, and I think they're selling them for around $90,000. I think that's what I saw on their website, around $90,000 basically for research organizations. So this is what they're looking for. They realize that we can't do it all ourselves. We want to get it out there. We want people to start solving these fundamental problems. And it doesn't have, you know, full-fingered hands. It has basically little stumps on the end. But for all intents and purposes, it gets about everything else you need. That if you want to start solving some of these problems, you know, it's there, and you're going to see more and more. And trust me, it's like every university right now, they realize if they want to have a robotics program, if they want to attract some of the brightest talent to come and work in their graduate programs, they're going to be getting one of these bots in there. If not from Unitary, then probably from some of the others. And I know there's some others that are also very close to sending them out as research. And even them, they're like, our bot's not done yet, you know, yet everyone wants to buy it, you know. So I guess we'll give it away, or I guess we'll sell it to them if they really want to, with the understanding that, you know, it's still not complete. We're still trying to work on it. And everyone's like, oh, fine, we don't care. We just need something to work with.
Maybe before going to figure, I'm curious about the landscape. Since Unitary, it seems that it's advancing. I don't know your vision about these companies, but it seems Unitary a bit advanced a little bit compared to other companies. I'm not sure you agree or not.
I mean, what's happened is that I kind of see it. It's almost like an Olympic decathlon right now. We have all these different events, and as you run one of the events, one of them can say, "Oh, you know, I'm the champion on this particular event." So when it comes to walking, Unitary wins that hands down. But there may be other areas, like it doesn't have fully formed hands, so it doesn't have the dexterity there. And so as far as like, you know, a really fully formed hand, you might say, well, Sanctuary seems to get that nailed down pretty well. And then you may look in some other space, but what about, you know, who's got the best way of being able to teach the bot right now? It's like, did Figure with that coffee maker thing demonstrate something? Because what they demonstrated sounds awfully close to what was going on in Carnegie Mellon, that, you know, they're just like videotaping what people are doing and suddenly getting that. So they're all sort of doing the same thing. And you might say, yeah, but, you know, the overall winner of the decathlon, even though Tesla didn't win any individual event, maybe is a Tesla bot because it just looks more elegant. It seems to be more complete in some others, or maybe not. It's basically, it's a horse race right now. I could not say who is. And I don't want to be in that position of saying those guys are number one right now. I just want to point out what's going on, because I want to remain as neutral as possible, because I'm basically cheering on the whole field, you know. And it's almost like when one horse gets ahead, you're like, everyone's like rooting for the other one. It's like, that's when I watch the Super Bowl, that's, you know, it's like, who do you want to win? It's like, who's ever behind. that's the team I'm rooting for. And as soon as the lead changes, I want the other one to come in there. So that's what I'd like to see. Okay.
So one of the questions is, I think, you already interviewed Brett Cook, the CEO of the Figure AI. And to be honest, I asked even people in the robotic community, even offline and online, just what do you think about it? Because there was also division about, the first question is why all this big player invested in Figure AI and none of others. That's one of the question. And the second question is, what's unique about Figure AI?
Right. Well, I think part of it is there's not that many investment opportunities. So if you look at the humanoid bot space, there aren't really any that are publicly available or publicly trading that you could invest in right now. So the only play is Tesla, but that's kind of indirectly. You're investing in Tesla, the company, where Optimus is sort of part of it. The others are just, you know, private rounds, and that's what Figure did. That was a private round. So you have all this money that's on the sideline right now looking for some place to go. And there's only a few players in the US, And those other players, they will be getting capitalized soon. Don't worry, because Figure was already oversubscribed from what they wanted, which meant there were a lot of people that wanted to get part of that couldn't. That want to look somewhere else. The other thing is that the total addressable market is so big that it's not like there's going to be a winner takes all. There's going to be other opportunities. And many of the people that are investing in Figure also are investing in the other companies as well. So a lot of them are basically placing their bets right now because they see the overall market. Now, with Figure, part of it is the track record of Brett Adcock. Now, it's a little controversial. Some people, I think, unfairly compare him to Trevor Milton. I think that's a completely wrong. It's misplaced to look at it that way. He's started up a lot of companies. He's learned a lot about starting those companies. He's been able to exit those things. But it seems like in every case, things went ahead the way kind of you expected. Now, he had this last company, which was building a VTOL, and went public and everything else. And the company is still out there. It's just they're basically waiting for like FAA regulation and everything else. And it just seems like someone that is like impatient, that just wants to get stuff done. And so he saw that, there's a huge opportunity over here that's even bigger than the VTOL market. And he had and he always wanted to do something like that. It's like every kid that grew up, they read Isaac Asimov's Foundation trilogy, and the next thing you know, it's like, why don't we have humanoid bots? So he was able to put together, because he's already had the ability to pull teams in as well as attract the capital that was necessary. And I think the other thing is that he is a go-getter. He's the type of guy that just, he wants to get stuff done. So he's impatient. And some people like that because he's driving the team. He's getting results really quickly. Some of the other bot companies have been plodding along. So, one of the problems with Boston Dynamics is they're still an R&D company, and they still don't have plans to do much with a humanoid bot. They've got the Spot Dog. They've got some other things they're working on, but they've publicly said, we don't know what to do with the humanoid bot. So everyone's like, okay. And their mentality has always been more R&D, taking a very long term. Some of the other companies are also, let's say, not moving quite at, say, that speed Figure is. And Figure is the only one that's moving at Tesla speed. You can just sort of see both teams are going out there and working very hard. Okay, but also let's look at the Chinese bots because they're moving at light speed well. Because one of the things that Figure was very proud of is how quickly they were able to get a walking humanoid bot. Well, that was probably eclipsed by a couple of Chinese companies that they're all doing it in under 12 months now, which to me is just unfathomable that that's possible, when a few years ago, everyone was just talking, it's really difficult. You've had these universities working on research projects trying to do it. It's like, walking, it's really hard. We just don't know how to do it. And now everyone's doing it. It's like, so there's like some fundamental breakthrough. One of it is that they basically understand the problem better. It's taught in universities. There are research papers out there. The control systems are better. And, my overall feeling is everyone's like, what sort of led to the breakthrough that allowed it to happen? And I said, the day I saw the Segway come out is I said, okay, they've just solved walking for bots. And now you might say, well, wait a minute, what's that got to do with it? The Segway is a wheeled vehicle and stuff like that. I said, yeah, but it's the inverted pendulum problem. It's this idea of having a control system that's able to balance a pendulum before it falls over. And then you put a human on there and stuff like that. And then it's like, okay, the technology is there. The control architectures are there, that it won't be very long before they can solve bipedalism for sure. And so I'm pretty sure a lot of the techniques and technology from the Segway has kind of made it into these robot chassis to allow them to do it. Now, yeah, it's a little bit different. You basically have a double pendulum problem and you got two of them as opposed to one, but it's the overall same thing. And that's why they're all able to do it really quickly. And right now, they realize you got to place your bets quickly. Or, the other analogy, the train's leaving the station. If you want to get on, be part of one of these companies that is going to be producing a humanoid bot, you got to start looking around now and start, finding the companies or finding people, the startups or the R&D team, which you think is going to do this. And I think Figure is well positioned to be able to do that. And I would not discount the ability of Brett to kind of keep his team together and keep it moving forward, because he's got a good quality team. And the Figure bot is done, it's one of those things that you could be both impressed and not impressed by. You might say, it's looking kind of slow, I can't do this and that. And it's like, first, you don't realize how much they solved in a very short period of time. Second, it's not about the speed. That's all stuff that will be taken care of later. And the other thing, which seems to be, the cliche of the month, is these bots are the worst they'll ever be. And that really is a case that's not the end design. That's their first design. It's going to be eclipsed pretty soon with their second design and then their third design. And they will have learned a lot and they will have moved ahead a lot. And then you'll be kind of surprised, like, oh, wow, they are really making progress there because they understand it. Because to me, the mechanics, some of those issues can be solved when they need to be solved. The real thing is understanding how to train them.
I'm curious about this competition between the Chinese market and the US market, because it seems they're moving very fast compared to the US market. And you mentioned that maybe, I don't know, it's work ethic, it's just maybe how the education for these engineers may be better. I'm not sure what are factors, but how do you see this competition would shape the coming, next year, for example, the plan for next year. So how it looks like?
Okay, I think, first of all, there was already some interest in China right after the Tesla bot came out. There's always been like interest in it, but up to the point there was sort of a stigma associated with the idea of being associated with the humanoid bot. No one took you really serious if you were doing that. So a lot of researchers stayed away from it. And then when Tesla made that announcement, they kind of were able to get rid of the stigma around discussing it and thinking about that. And so suddenly everyone could come out of the woods now and say, "Ooh, okay, we can start actually researching this." And that kind of validated it to many research organizations. And especially in China, there were a lot of companies that looked at that and said, "Oh, okay, this is rather interesting." Meanwhile, there were a few that kind of stumbled into what they were doing unintentionally because they had other research projects that were going on where they need to do these things. There's going to be an interview with Herbert this weekend where we interviewed the chairman of, or the CEO of Fourier Intelligence. And they were in basically healthcare and rehabilitation and designing these exoskeletons that had to have servos on there for patients and stuff like that. So they knew a little bit about biomechanics and how to make these arms and legs and stuff like that would help people with walking motion and everything else. And they just kind of wondered one day, oh, can we take some of these things we hear, like throw them together and make a humanoid bot? And they did, and start working to their own surprise. That's like, holy cow. And so again, it's like, what's going on here that's suddenly so easy to build this thing that we couldn't build a decade ago? And so they suddenly realized that they had something here, and they weren't sure if they should go ahead, and they get a lot of encouragement. Then at the same time, you have President Xi make that initiative announcement on what they want to do. And at the same time, I think most countries, everyone was still kind of laughing at the idea of the humanoid bot. They weren't taking it seriously. And it's just like, oh, that's Elon. Yeah, well, he just has crazy ideas, so we're not so sure. But the Chinese looked at it and they said so, and then they came out as a country and did it. And then I was expecting other countries to react, and the other countries are like, okay, so what? Well, I thought some others would start to get an initiative, or others would announce the same thing, that the European Union would think of something. Now, it's a little bit different in the EU and the US, but you do have like these grants, these NSF kind of things, or these challenges they'll put together to try to focus research in a particular area. And I thought, oh, when are they going to start doing that? Or were there going to be more companies working on that? And there was like no national initiative coming from anywhere except coming from China. And we've been talking about kind of this competition of maybe the US with China, but that's not really the elephant in the room as far as I'm concerned. Or let's say the elephant not in the room is like, where's Japan? Where's Korea? I mean, Japan led the world in industrial robots, and I'm wondering, they should become. I mean, of course, they had Asimov. They kind of already had something, and they seem like either they're doing something really quietly, but I would be expecting something coming out. I'd also be expecting some kind of Korea, because Korea also has a big force in the robotics area, and it's not so much in the traditional industrial robots, but more in these cobots, which were these smaller, slimmed down industrial arms that are already designed to work next to humans. So it's like, you've already got some people that kind of had the tech in the background. You should be able to do it as well. And so I'm not sure if, whether they're not taking it seriously and think of that. And the same thing, it's like all the major industrial robot companies, not one of them has a humanoid bot initiative. Not one. You think they would. None of them are announcing it. Yeah, I mean, they get some arms that are kind of human-like that they put down there, and some of these other kind of little torsos they've been wearing, but none of them are really thinking, okay, we're going to make a humanoid bot. And so again, that's, to me, it's like, what's going on? So I still think the R&D area is a little bit divided on the utility or the practicality that this is going to happen. And so they're just thinking, oh, it's a couple of crazy guys like Elon and Brett that, they're really good at getting the capital investment, but this is never going to pan out. That's probably what some of them are thinking. Or they're sitting on the sidelines and waiting for something. And then when they see something good, they will then jump. So it's quite possible that some of the industrial robot companies are waiting for some company to develop something. And then they'll swoop in and say, oh, okay, we'll partner with you now. Eventually, they're going to have to. Eventually, there's going to be a connection between the humanoid bots and the industrial bots. The industrial bots aren't going away. Trust me. It's like those big specialized bots. It's not like we're going to say, oh, we just replace them with a bigger, stronger humanoid bot. No, they're specialists on what they're doing. They're going to work well. However, the interfaces between them, you're going to want them to be able to talk to each other and to talk to each other in a very good way. So eventually there's going to be standards and stuff like that. And then usually, if you're an industrial robot vendor, you're going to want to either have a partner or you're going to want to have that part of the solution offering that you have and say, oh, by the way, it's like, you come in our spot welding bots here, but, we've got the humanoid bots to actually tend to the cell and to feed all the components that are needed in there. So you will see that. So I don't know if that kind of answers your question or if I went a little bit off topic there, but I mean, that's kind of how I see what's going on, is that there's a little bit going on in the US, not because the US government said, do it. It's just that a couple of companies, because it's more or less the capitalist mentality in the US, when they see an opportunity, they just start doing this and they start working in that space. But then in China, it's more or less that it was seen as a vision and agreed upon by a lot of people. And the other thing to remember about China is that they graduate 10 times more engineers per year than the US. So I keep on saying, this is what happens when you have 10 times the number of engineers in the US, is that you can do great things. You can have more than one company solving the problem. You can have a lot on there. And so that's something that the US and I think a lot of other countries think is like, hopefully you don't have any lawyers here, but I mean, we graduate too many lawyers and too many MBAs. We really need to start graduating a few more engineers because, if you want to compete in the upcoming world, you need to make sure you have the people that know how to create these things and not just the people that are managing, because, if nothing being created, there's nothing to manage.
Maybe I'm curious about the design again, actuator, because you mentioned at the beginning that, like, for example, Tesla, for example, they have custom-made actuator. And also the linear part, like the linear actuator versus the rotary one. When you interview these companies or just look what they did, the choice to design the actuator that way, what are the approaches they take? Like, can you tell me the consideration to go for this or that?
Yes. So, the first thing is you have to understand what your power requirements are going to be. So you've got to come up with some sort of specifications that you want the bot to be able to walk at a certain speed, be able to lift a certain amount. And also you're concerned about runtime. It's like, okay, I'm going to have a battery pack on there. How heavy is the battery pack going to have to be? And, if it's of this size, I can only drain it at this rate if I want to get 8 hours out of it. So you're kind of looking at all those things is to sort of start out with. It's like, okay, I've got these specifications I want to have. Now, what is my actuators going to be like? Well, if you're going to be building a car, you have to size the motor for the requirements that you have. So if you want to have a car that accelerates really fast and has really top speed, well, you're going to have to build a motor that just has like a lot of power. And that's why you design something like the plaid motor. But if you're looking for something that's just going to go around the city and doesn't have to be really fast, then you'll make it a bit smaller. And that all comes down to you deciding, well, how heavy is my vehicle, how fast does it have to go, and you can calculate what the torque requirement is for that particular motor, which allows you to size it. You do the same thing with the humans, except the humans is a bit trickier. You just can't say, oh, I want to be able to go from 0 to 60 in 8 seconds, and I want to have a range of 200 miles and a top speed of 80. Which would just be that simple. And from that, it's very easy to figure out how big the motor needs to be in a car. But a human, we do lots and lots of tasks. So we sit, we walk, we stoop, we carry things, we grab stuff like that. So what they all did, and Tesla was very explicit about this. They showed it in their AI Day 2 slides and how they went through this whole process. They simulated the walking motion of and in order to accomplish the speeds that they needed, they were able to find out what the torque and force requirements were for all the actuators. How much would they really need to be able to lift that load? How much would they need if they were walking? How much would they need when they'd be sitting down to get all those ideas? And so they knew that, okay, this is the maximum we need out of each of these different motors. Now, the problem with the human body, we have hundreds of degrees of freedom. The And now the humanoid bot is a simplification of that. So the first Tesla bot didn't even have movement in the neck. It wasn't there. They now decided to have 2 in there. But the thing is, you really can get 3 degrees of freedom with your neck. So you have like the nodding, you have kind of like the back and forth, yes, no, and you have this one to the side. And now this one to the side, the Tesla bot can't do, because they said, we don't need the actuator for that. And at first they said, we don't have to because we get 360 vision, so we don't have to move our head. And then they decided, for some reason, they have to move their head. And that might be for socialization more than anything else. So that, if the bot's looking at something, that's what it plans on doing. So they decided we don't need that degree of freedom. But other bot manufacturers have decided that they want that degree of freedom. I know Sanctuary AI has done that. So they add one more servo in there. And they have said they originally had 5 degrees of freedom, because it turns out our head's a little bit more. We've got like a pivot point down here and a pivot point up there. So if you really want to get the motion of your head correctly, you need more degrees of freedom. Our spine is something else. It's really tough. So a lot of them are like, look, we're not going down that path. Rather than having hundreds of degrees of freedom, we're going to cap it somewhere around 40, 42. So the Tesla now has 42. Some of the others have like around that same number. So it's in the order of 40, where pretty much you have 12 of them coming from the hands alone. So from the standpoint of what they call the structural actuators, you've got somewhere between 28 and 30 structural actuators that are going to be there. That's what's going to be lifting the load, moving everything else and all that. So they looked at that and said, but even then with 28 degrees of freedom on the structural actuators. Now, so the hands, you could say, well, do the servos all be the same in the hands? And the answer is, I guess, yes, they can, because that's what they decided to do. So it's like, okay, we're going to use the same servos in there and not going to have 12 unique servos. So we get that out of the way. So we've got the hand servo off to the side. Now we have 14, or you basically have 28 degrees of freedom, 28 structural actuators. That means we need 28, right? It's like, well, no, symmetry. Don't forget, the human body is symmetric. So that means it comes down to, you probably would need 14 unique actuators, right? It's like, well, not really, because some of them, like in the shoulder, are so close to their requirements that we can use the same servos there. And if I say servo, motor, and actuator, I mean the same thing. So excuse me if I sometimes slip into like this other vernacular here. So they basically have 3 of the identical here. So that means, okay, we don't have to have that set. And it turns out one of those motors also is like perfect for down in the hip, or the hip and the leg, right in that area. So they popped one down there. And then they looked at what they needed for the elbow. And it turned out that the linear actuators that they decided to use in the elbow, they can also use down in the ankles. So it's like, that fit pretty nicely there. And then they also have, like, for the wrist, they needed 2 for the wrist on each side. So they got 4 of them that are there. And so in the end, they ended up excluding the hands. So the 6 actuator designs, 3 rotary, small, medium, large, and 3 linear, small, medium, large. And the big linear drive is the one that they showed lifting the piano. And so that's impressive. So you're looking at that, and that's what they're putting basically in the hamstring and the quad. That's what's making the knee go, and that's what's making the leg go. So they get something like that. So you can imagine, wow, that's got a lot of strength if it can lift a grand piano without gearing. I mean, that was like direct on there. You're seeing that thing going up. That's a lot of power, and it's lifting it at a rate of, I don't know, it was somewhere like maybe 1 inch a second or something like that, a half inch, somewhere around there. And I figured out, like, wow, I mean, that's impressive. How much power do you think that needs? If you were thinking of watts, I mean, just think of how much wattage do you think it would need to lift a grand piano at that rate? And now, just to put things in context, about when you plug a hairdryer in, the hairdryer, I think, is usually capped off at 1,500 watts. Okay, so that's, coming out of that. Now, how do you think it's more than a hairdryer or less than a hairdryer to lift a grand piano? What would be your gut instinct?
Maybe less.
Turns out to be less. And it turns out to be way less. It's like 180 watts. So it's less than 200 watts to lift a grand piano like that. And now they say that they want the bot to never exceed 500 watts total. So when it's operational, that's what it would be doing. And that way they can at least get 4 hours out of the battery pack at maximum. At more average, you might be able to get 8 hours. So it's beginning to show. At first, you would think, the bots, those batteries are not going to last that long. And then you realize, holy cow, it's only 200 watts. That means that battery pack that's in the Tesla battery pack can lift that grand piano for, like, I think 9 hours straight. It's just like, yeah, it's just going to keep on. So you're thinking, oh, the batteries are going to wear out in no time. It's like, it's nothing. It can just keep on doing it and doing it and doing it for quite a long period of time. And of course, it doesn't need to lift a grand piano on its leg. I mean, grand piano, I think it's a metric ton or something like that. It's just incredible. It's very heavy. It would be a half ton. No, so I think it was like it was a kilogram. So I think it's a metric ton. I have to remember it, but it's a lot. It's way more than the mass of the bot. So you can see that the motors have the power when they need it, but then they also have the energy density. Now, the big question is, why rotary versus linear? And again, that comes down to the mechanical engineers deciding what's going to give like the right torque characteristics and everything else. Because sometimes you have the linear drive, it's a bit more complicated as far as the actuation. So with a linear actuator, it can be both the joint and the motor at the same time. So you imagine if I take my elbow and the hinge joint that's in here, if I just replace that with a motor right there, well, guess what? The motor and the hinge joint are the same thing. So that's simple. Whereas when you do it with a linear actuator, you actually have to have a hinge here. You've got to make a mechanical joint here. Then you've got your actuator way back here, which has to have the piston and the rod. And it has to have an attachment point here and an attachment point there. So it becomes mechanically more complex to build something like that. So you have to have a compelling reason on why you need to use that design versus something else. Now, in some cases, it's compactness. So when we get to the wrist, our wrist is very thin. And if you look at some of the other bots that are out there, and this is something that Figure is going to have to be working on, is their wrist is like really bulky because they're trying to put 3 servos in here because they need to get 3 degrees of freedom of motion in there. And when you put those things there, your wrist gets so big. And now it's like, oh, okay, the hand can move, but it can't get into spaces. You want to go up in the cabinet and grab something, it's going to be bumping into stuff. You want to make it thin. So you want to do what the human body does is that our motors are back here in the forearm, right? And we use something else to make it articulate. And so what Tesla's decided, look, we got that empty space back there anyways. Let's fill it in with a linear actuator. Let's use these rods that are pushing around that are going to make the hand move. The other thing that rod mechanism does is that when you put the servo drives in your wrist, a lot of times you get way more motion out of it than you really need. So it's almost like an over design. And you might say, great, look, I can make my robotic hand do things that a human can't do. So I'm going to make it superhuman. And there was, I think, I'm trying to remember the name of the company. I think it was like UBTech showed something like a week ago working on the Neo line where the robot arm went in there to do the seatbelt tension. And it's like, did something that's like very unhuman as far as the way the hand went in there because it had motion that a human hand doesn't have. And the idea is that we don't really want to make them superhuman. We want to make them the same. So we have a limited range of motion this way and that way. And because of this limited range this way and that way, and especially this way, and this is what's called the yawing on it. And I like to call that, it's like, well, what motion is that? If you don't know what it is, I call it, that's the metacarpal syndrome motion. So the one that when you're typing, that is really hurts your hand a little bit. And you'll notice you don't like moving your hand in that direction. You can a little bit, but you really don't like moving it that direction. So why design a servo? Put a big, bulky, heavy thing there just to give you that little bit of motion. So the design that you see for the Tesla forearm there is designed to give you just enough of that motion, but not more. But it gives you a lot this way. It gives you a lot where it needs to be. And what's really cool is that those two motors, because they're in parallel, can work together, which means when you need a lot of strength in that direction, all those motors work together. If you have only one motor there and one motor for doing this, that motor's sitting there doing nothing, going for a free ride and not helping you out at all. So again, there's like this advantage to the parallelism. It gives you the slimness of the wrist. It moves everything back. So that's part of what they're designing when they're looking at it. And now, if you look at Figure is almost exclusively rotary. They have like one place with linear drives. And it's like where I didn't expect it. It's down in the torso. So the movement they have down there is actually done with that. And it's like, well, that's kind of unique. And I'm not sure if they're going to continue to do that. But, it seems like they put it in there. But everywhere else, they didn't. And I was expecting, wait a minute, you need the knee for sure, you need to put it because you need the power in the knee. Everyone else is kind of doing something like that for the knee. So they decided to go almost all rotary. And a lot of the Chinese bots are also the same. You look at them, they almost don't have it except if they might need it for the wrist mechanism, something like that. So a lot of them are just really going all rotary. So But then there's another company, Aptronic, out of Austin, Texas, and they have this Apollo bot that they've been working on since about 2015. So that this group goes way back. They did work for NASA and everything else. And they've looked at it really closely. So, I mean, you want to ask the question about designing your own actuators. These guys, they've drilled down, they've looked at it, and they've come to the conclusion that linear actuators are better in every single case. And part of the cases is they believe that they're actually cheaper to manufacture, they're more compact, they give more power that they need, and it turns out they're more energy efficient. They're like 95% energy efficient versus 70% for rotary actuators. So they're like, that's the design. So they're the polar opposite of Figure. So I put Figure up in the North Pole, and these guys way down in the South Pole, because they're like all rotary. I mean, all linear, even where you don't expect it. Like even the shoulder, they don't have it. And I was like cheering, like, yeah, someone has like come up with a different shoulder, because I think we're finally going to get that ball and socket that I'm looking for. So they said, forget it. We're going that route. So they're literally polar opposites. And then if you look at the Tesla bot's at the equator. It's a little bit of rotary and it's a little bit of linear. It's kind of the two of those that are mixed in there. So that's kind of a summary, a little bit what's going on. But yes, they're all designing it because they need the compactness, they need the energy density, they're looking for efficiencies. And it all comes down to you've got to do the analysis, you've got to do the simulation of how much energy and power is needed for these things to make sure I have something that's the right size. I can't make it too big and I can't make it too small. I've got to make sure it's just right.
Do you think Figure will change a little bit, combination of the linear also?
They could. I think when they come down to the wrist, so I was really surprised to see this H1 bot. From what I can tell, it looks like its knee and some others are using rotary actuators. So I'm surprised where a lot of these Chinese bot manufacturers are using rotary, where I was expecting linear in the legs. Now, down by the ankles, almost all of them, except, Figure is still using rotary ones down there. They're using kind of linear drives for that. And again, because with your ankle, you don't really have full movement in your ankles like your wrists. So your wrist, you do have 3 degrees of freedom. But like I say, that third degree of freedom, it's almost like it's not there. You could almost pretend it's not. As a matter of fact, the original Tesla bot and Tesla bot design was, they said, that's not an important joint. We're not going to put that in the hand. We think it's a waste of time to solve. And then later on, they realized, you do need it a little bit. So that's in there. So we have the 3 there. But when you look at your foot really has mainly kind of the forward flexion motion there. And it has the side to side, like when you step on something, you go to the side. But it doesn't, the movement that we think of like being pigeon-toed and duck foot going back and forth, that's really motion that's happening more up in your hip. It's not happening below your knee. Some people think you need something down there, but if you actually try doing that with your leg, you're fine. It's really hard to get that movement. And that when you really want to have your legs spread out, it's more or less your knees are moving out. If you keep your knees straight and try doing that, it's pretty hard. So it's almost like, don't worry about that degree of freedom. We just need that little bit of side to side. So when we're on an uneven surface, we don't fall over. So the main motion you want is this. And you want that for a couple of reasons, because that gives you the energy in your motion. So again, it's going back to the same wrist design, that you can do these 2 linear actuators that will give you an extreme power when you want to make your toes go down like that when you want. But by being differential motion, you can give a little bit of that side to side if you need it, but just enough. Because again, try rolling on the side of your legs a little bit and your foot. And you can't do very much. You're not doing 90 degrees plus or minus. You're not even doing like probably plus or minus 30 degrees. It's just a little bit. And you go beyond that, and it's what we call a sprained ankle. So, So they're all going to be putting in some places, because I just don't see how you can make such a compact design that would be rotary at the wrist and provide the power that you need. If someone's able to pull that trick off, that would be really something else. But right now, it seems like the only way is to kind of do that. So I would imagine in the future, unless they get some real tricks up their sleeves, no pun intended there, sometimes they just come out and I don't intend it. That they will come up with a design that's probably different. And again, they will work on that and they will learn more and more and more. And that's why it's sort of exciting that they're moving at such a pace that 2 months from now we're going to see a new bot, and then the next 2 months after that we'll see another.
I want to take your opinion about the agility robotics, since the leg is based on inspired by BERT. and it's Jonathan in the podcast 2 times before, but he spoke about it's a human-centric, but it's not humanoid. So that's his approach. So we're looking for agility robotic, the design of the legs, and also we have X1 Technology, the Norwegian company. We'll also interview them next month, the CEO of the company. But again, they use a wheel here, the different legs. How do you see the approaches versus figure, for example, in Tesla? Like, do you think there's consideration? Do you go for the wheeled or an inspired leg by Bird, for example, at agility?
Yeah, it's going to be one of those things where everyone kind of goes back and forth on as they start learning. So my understanding is that that's the EveBot, which was the first one. It makes a lot of sense when you're trying to ramp up really quickly and you're trying to solve a lot of problems. You say, oh, we've got to come up and we've got to teach these things to have a certain amount of mobility and dexterity and everything else. So you decide, do I build full hands or just like put a claw in there for a hand and be able to grab and reach things and just deal with the fact that I don't have enough dexterity? And do I put it on a wheeled base so I don't have to solve this bipedal problem, but I still can have to solve the navigation problem? I still have to get the bot to realize it's got to go over there and understand, oh, make myself go over there. And if that's done by a wheeled vehicle or bipedalism, that doesn't matter. But they're working on their next version, which is the NeoBot, which is going to have a full working hand and has legs. And they may dispense and just use that going forward. So their overall feeling is that once they crack that, it may actually be better to not use the wheels. Now, the problem with wheels is that you end up having literally a bigger footprint, and that in many spaces to get in there, the wheeled vehicle bumps into things, whereas bipedal, you can get in more easily. So in order to keep stable, so even though it seems like it's be an easy stability problem, it's not quite as stable as you want. Now, there's some advantages that it can pivot really quick. So a lot of the bipedal bots right now, they don't pivot quick enough. They're not ballerinas. They can't do a pirouette, and they need to do that to be able to grab something from one place to another. So that's one advantage of the wheels, in that they can go fast and they don't use a whole lot of energy. But they have a problems with some surfaces. And, X1 is a Norwegian company. And if you look at the office space, the way it's laid up in there, you go to any Scandinavian country, it's cold up there. And the result of that is every doorway has a door jamb. So that when you close the door, it makes sure there's no draft going underneath there. And, usually like a lot of Americans, when they show up for their first meeting over in a Scandinavian office and they go to walk into the conference room, the first thing they do is they trip because they're like, what's this? They didn't expect it there. And that means that's a problem for the wheeled vehicle as well. So they've got all these ramps all over the place. And that is because they've got to deal with the fact that they got a little thing. So you have to reconfigure your workspace to make sure it can go over. And they're realizing, if it's bipedal, we don't have to worry about that. So there's an argument back and forth. And even those that are working on bipedalism say, we don't discount in the future that it might be easier to put it on a wheeled base for certain applications. Oh, and by the way, there's going to be some applications where you don't even need the legs or mobility. We just plop it on a table and it's just there, and we just have the arms, and that's all you need. So again, that's why I keep on saying they're all right and they're all wrong. There's going to be an argument when wheels make sense and when they don't make sense. And then, kind of getting to agility, they have a very unique design, and I do like their design approach. And I like each one of them because they're attacking the problem from a different way. And it's refreshing to see that someone else says, we're looking at this way. So agility, they literally designed it from the ground up. They solved the walking problem first. And they looked at it and they kind of came to the conclusion that this, what's called a digitigrade form of walking, which is what an ostrich looks like. And it looks like the knees are backwards, but technically that's just that it has a really tall ankle. What you're seeing there is the ankle and not the knees. The knees are up very high by the hip, almost hidden there. So it seems like something's very awkward, but it's also very good for balance. And it has this huge advantage that when you go down to grab a box, their knees don't stick out and bump into the box. So it's like almost perfect that you'd want to have them backwards. I'm sorry, they're not knees, but I will refer to them as knees because everyone thinks their knees kind of go the other way. And so they've been very good in the walking problem. And then again, he was like, what do we do with this? How do we make it useful? And they're like, we don't want a humanoid. We don't want a humanoid. And they kept on fighting. And then unfortunately, or fortunately, they realized that the best design for that human-centric kind of thing was to have a torso with arms on it. Now, I really loved their first arm. So their first generation arm, it didn't have hands yet. And because it didn't have hands, it needed to have a full wrist. And so they had limited degrees of freedom on it. They only had 4 degrees of freedom, 3 in the shoulder and 1 in the elbow. And they had stumps for the wrist with a ball on it, which meant, they could pick up boxes and move it around and stuff like that. And what I liked about the wrist is that they reorganized the order of the servos compared to the way others had it. And it gave it a kind of motion that I really liked. And then when they came out with the one with the full wrist, the new 6-degree freedom, they went the same old way as the traditional one. I was like disappointed. Like, oh, come on, guys. I really liked your old design. What was wrong with it? So I hope to interview them and ask them that very question. It's like, why did you pivot? And again, these bad puns from the kind of shoulder that you had before to the one you have now. What are the advantages or disadvantages you decided to do it? Because when I looked at it, it had the effect is that it turns out the human arm actually has 8 degrees of freedom that people aren't aware of. A traditional robotic arm is only 6 degrees of freedom because it's all you need. We live actually in a 6 degree of freedom universe. You may not know that. You may think it's 3D. And when I say it's 6 degrees of freedom, we have 3 degrees of translation and 3 degrees of orientation. That's why there's 6 degrees of freedom. So if you want to be able to pick up something from any position and orientation in space, you only need 3 degrees of freedom in your arm to be able to get to that position orientation space. Anything more is considered a redundancy. Now, the human arm has redundancy in that we can keep our wrist kind of fixed in space, and you see my elbow can go up and down. Now, to get to that position in space with a mechanical arm, a human robotic arm, there's only one way it can get there without doing that. It doesn't have the redundancy. And that's because our shoulder is a ball and socket joint. That's what allows us to do it. So that's usually say, okay, but where's that mysterious 8th degree of freedom you're talking about? This thing called the scapula. You see how I can make my shoulders go back and forth? The torsos don't have that in the humanoid bot. They're not there. You don't have that scapula movement. And every biomechanic I'm talking to, they're like, oh, the scapula. We want to see them put the scapula in there. And the first, the CTO of Sanctuaries, Suzanne Gildert, she was the first one to bring it up because I asked her, I said, this is the question I love asking all of them. If you could add one more degree of freedom to your bot, where would you add it? And if you had to take one away, which is the one that you would throw away and for what reasons? And I've got some interesting answers. And from her, she absolutely, so Brett was like, he was having a hard time. And I understand because they optimize these things to the point that they're like, you're asking me which is my favorite child. You don't ask that kind of question, right? So it's like, yeah, maybe the pinky because they had the discussion, but it really is. And then a lot of times if they ask to put another one in, they say, well, I guess maybe we put one more in the torso or the neck, but it's almost like we're not sure if it's really necessary. But from the standpoint of Sanctuary, they've got a lot of those. They already have 3 in the torso. They already have 3 in the neck. So it's like, you're running out of room here. Where else are you going to put it there? And she's like, the scapula. We'd like to put it in the scapula. And that just stunned me. It's like, oh, wow, really? Great. So you want to have that. And then the other one that surprised me that you'll find out on our interview with Zen Ko is he says there's another one he'd like to put down in the hip. And I'm trying to figure that one out. It's like he just said that he'd like to put one down. I said, but wait a minute. You already have all the degrees of freedom you need in the legs. That's a 6 degree freedom leg you got there. You've already got 3 degrees of freedom in your torso, whereas the Tesla bot just has 2 and some of the others only have 2. It's like, where are you putting that other one? I can't figure that out. So again, sometimes you're surprised when you ask that question, what the answer is, which is why I want to do it, is to get an idea because they've thought these things through and they probably had the designs and they probably had to X out a bunch of things. And then they probably came back later on and realized, whoops, we took one out that we didn't, or a couple out. Tesla did that. Tesla, the original design, they had a 6-axis arm. And I was like, oh, okay, I can kind of see why they're doing it. I'm not sure. And so I wasn't surprised when they came back and added one more. And then they took it out of the neck and then they realized that was a mistake and they put it back in the neck. But just kind of going to putting something in and not sure you need it and then putting it out is that Tesla first started without any sensors in the hand. And the second generation bot now has sensors in the fingertips. So they decided there's some importance to putting in there. They thought they could get away without it. I thought they might be able to get away with it as well using what they call back EMF. That anyone knows that, like, if you're using a drill or something and it gets stuck, and you're doing it, it's like, it starts making lots of noise. It starts drawing a lot of current because you suddenly stop the motion of it. Well, if you measure that, that can tell you something about what you've come in contact with. Same thing with a hand. You go to grab a bottle and like your hands are easily closing down. As soon as you hit the bottle, suddenly, we feel it in our muscles. Our muscles tighten up. Well, the motor does the same thing. And that back EMF is basically sending a signal to the control system to say, hey, that current is like suddenly to something you didn't expect. And that's telling you that you're coming in contact. So they were using that as sensors. But they decided, we need these tip sensors to really be able to do what we want. Okay, Figure's been doing the same thing. And they also designed it right from the beginning, their first bot, to have sensors in there. But they're finding out that they can run it without sensors. So they'll turn the sensors off and they're getting the same results without it. So they're almost like, we don't need it. So I think this is really interesting to see these different design teams are coming in from different approaches. They're coming up with different conclusions, and they're almost like flip-flopping on that. And it'll be interesting to see whether one of them kind of comes back or goes down, or whether it's like, well, it depends. If it's going to be in the kitchen dealing with eggs, we got to have the sensors on it. But if it's working on the shop floor, scrap it. We don't need them on there. Everything will be fine without it. So that's what you might end up seeing. Yeah, exactly. Drive the cost down. Mm-hmm.
Awesome. Maybe a few questions here. What do you think missing so far based on what you saw? Maybe hype a little bit or missing that should be focused for the companies that work in humanoid robotic in general. Do you think there's something missing or maybe hype a little bit?
As far as the technology and what they need, all the major components are there. I think it's just a matter of getting more and more data, getting more and more training that they had to have. And, breakthroughs are going to be coming. So you're seeing all these papers and different research organizations that are coming up with different breakthroughs in the AI space, where especially learning with like video input and what's going on there. And I don't think it's a coincidence that a lot of them are finding some of the same results at around the same time. So they're all there. And that as you start combining multimodality into these LLMs, where LLMs is more than language, but now it starts to have vision, I really think the convergence will happen faster, because when you sort of combine two sort of orthogonal data streams together, they're describing the same thing, you can probably solve the problem easier. The problem is if both of your data streams are like the same, it may be confusing, what they call like sensor fusion. So Tesla had a problem with integrating the vision system with the radar, because they're almost similar kind of data inputs that can conflict with one another. And that's why I'm saying that they're almost like parallel streams of data that it's hard to tease. But when you have something that's more orthogonal, that's completely different from the other, but they're complementing at that time, sometimes you get the strength, your signal starts to strengthen as it's very clear that this is what we're looking for here. And then you get the convergence. And that's what I'm expecting is going to happen, is that, it's the compute that everyone needs to have. They just need more data and the right design. I don't see that their designs are missing anything at this point. Let's say at least eventually they'll get better. And the shoulders that we're seeing now, in 5 or 10 years, they'll be completely different. We're not going to see that, but that's the best they can come up with right now under a short time period in a certain amount of pressure. They don't need the perfect shoulder right now. They need that brain that's working. And once they get that going, you're going to start seeing a lot of finessing in different areas where things will be starting to get better biomimicry, because they're not really doing good biomimicry in the shoulder as far as I'm concerned.
Mm-hmm. Maybe the point about the OpenAI and NVIDIA, what do you think about what they already invested in a couple of companies like Figure, X1 Technologies. And also it's interesting when I see Elon Musk just suing, I don't know, you read the news about suing OpenAI and Sam Altman. So I'm just thinking about how this also play with the Humanoid saying things, both of them already investing. So do you think it's just like something play out in this like investment scene? I'm just speculating about.
Well, part of it is they're all looking for AI embodiment. So OpenAI and others, they already talked about that way back in 2015, 2016, but they felt that from the standpoint of scalability, they couldn't do anything at that point. So they kind of scrapped that idea. And then Ilya has said, oh yeah, I mean, now it's time to do that. That's obviously the next frontier that everyone wants to do. NVIDIA sees that as well. So they're partnering with so many different companies. They've come up with their platform called Isaac, again, from Isaac Asimov. That's like a development platform for a lot of these people that want to develop their own robot chassis. And it doesn't just have to be humanoid. It's like from, there's a company called Electric Sheep, which has, lawnmowers that are autonomous. And, they need to have that kind of navigation. That's a really clever application to, autonomous vacuum cleaners, to other types of robotic systems. So it's not just limited to the humanoids, but being able to solve that problem. So NVIDIA is making the right play because they realize, wow, it's like there's a gold mine out there, and but we're not going to be the miners. We're going to be basically selling the blue jeans and the picks to the miners, and that they're going to need the NVIDIA chip. So they see that for every humanoid bot that's going to be sold out there, or any sort of bot, that, piece of their technology is going to go in there, and it's very important for them to make that play. And the same thing with OpenAI. They're going to realize there's going to be a lot of licensing agreements, and certainly they came up with a good licensing agreement with Figure. And it could be partly the reason why Elon's been thinking about suing OpenAI for a while. So I don't think it was going to happen. It just happened to be coincidental that it was around that time. It wasn't, let's say, intentionally trying to say, oh, I'm going to come out with a suit now, because the lawyers had to go through and decide that is the suit ready to file or not file. And we don't know exactly what he wants out of the suit, except for OpenAI maybe to become open. I don't think that's going to have an impact on Figure moving forward, that they're going to still get access to compute. They'll be able to do it, because that was sort of the missing piece from them, is like, well, they got a small team, but where's the compute? The other thing is to remember is that the investment that came into Figure, and will probably be coming into some of these other companies, is coming from big players. These are companies that know how to do due diligence. So they just don't throw out $100 million investment here and there just because it's their gambling money for the week or something like that. They never want to be looked as a sucker. They want to make sure that when they do it correctly. They have a fiduciary responsibility to shareholders and everything. So you can bet they looked at it. A lot of the others looked at it, and to see those names kind of going in there in many cases sort of says that, yeah, they're confident that the humanoid bots are coming, and they're pretty confident that Figure would be one of those strong players. But I think overall, it means there's like just an endorsement of the humanoid bot field. That's the biggest takeaway I took from that Figure closing, was that it's showing that, and I've used this before, if no one's heard it, it's basically paraphrasing the great Arthur C. Clarke. And that is, the human bots will come 5 years after everyone stops laughing. And as we know, till now, there's been a lot of laughter about it. But once that stops and everyone gets research, and if you remember Arthur C. Clarke, that was a quote he made about the space elevator. But in that case, it was like 50 years after the laugh. And the laughter still hasn't died down. So I think we're still at least 50 years away from the space elevator. But again, it's that idea that you could have an absolutely fundamentally a breakthrough technology. And if there's a stigma, people refuse to do it because they're kind of afraid of getting laughed at. And now that people are taking it seriously, the money starts moving in there. The R&D starts happening. Other countries start taking notice. So it's going to be an exciting future.
We saw already Unitary in some labs already. Yeah, the research from UC San Diego, Carnegie Mellon. But when you see the academia and the movement versus what's happening in this investment, like in Figure, for example, do you think there's mismatch? I don't know if you have any comments about academia and what they do versus what we see, like Figure.
I think right now, I think there's a lot of excellent work going on in academia that is not just in the robotics field, but also in AI. So a lot of the papers you're seeing are coming from researchers like, at Stanford with the Aloha Project and others. And then, all you have to do, Carnegie Mellon's doing some interesting stuff. I think University of Toronto, University College London is working stuff. ETH in Zurich has also been doing fundamental things in walking bots for quite a while. And they have these collaborations with a lot of these other companies that are working on it. So they're not working in isolation. They are all teaming up and working together to solve these problems. So I think right now there's a pretty good cooperation. And again, a lot of what the academia is missing is they need the robot chassis. Some of them can kind of build it themselves, but that kind of takes a lot of time away and a lot of cost if they can get some off-the-shelf components. So that's exactly what the Aloha project was like. Just some off-the-shelf cobots that they bought and a few other things that they could build it. And then we're seeing these other universities are getting the Unitary bot. And I'm not sure how many are out there, but the fact that 2 of them already sprung up tells me that there's probably a lot that are moving that area. And you'll probably start seeing some other chassis showing up, but it may be a little bit further away because it seems like Unitary was like really quick to getting a design, and you can actually order it. You can get their webpage and you can put in the order for it. So that's a big step. Whereas the others are just like, well, yeah, we're working on it and someday it'll be ready.
Yeah. Excellent. So I don't know if you have any final words to say for people listening, like what we discussed. Any final remarks or words?
Well, I think, maybe just to touch on something that I referred to a little bit earlier, and that is what this is going to end up doing to the labor market. So right now, there's a labor market shortage. So there's all kinds of openings. In the US, it's still in the millions. and that the bots right now, when they start doing stuff, they're going to be doing very, very simple jobs. They're not going to be replacing extremely skilled or complex. They're going to be basically doing the jobs that most companies have a really hard time filling because they are just so tedious and boring. So they get a lot of turnover there. That means the other parts of the labor market that really need these workers, that they will now be kind of available there to go in there. So, and the demographic trend is it's not getting better, it's getting worse. So the gap is going to widen, and it's more or less the bots might arrive just barely in time to start filling those labor gaps. And while there's discussion of like, in the future, we're talking about billions of these things, we're not going to see billions right away. It's going to take a while before we see 1 million bots. It probably won't be till like 2030. When I speak to most of them, the CEOs and stuff, they're like, this year we hope to have 100, maybe next year 1,000. And then, Agility has already talked about some point scaling up to about 10,000 a year or something like that. So, these seem like big numbers, but that's still a long ways to get up to 1 million. You need to have a lot of them. So combined, you may see in the order of 1 million by 2030. That's not going to disrupt the labor market much at all. If anything, like I say, it's going to be plugging a lot of these gaps and holes. And that's not just going to be, 1 million in the US really won't affect the labor market. If you're talking about 1 million worldwide, it's like almost a blip. It will be later on when they start getting that scale, when you start seeing hundreds of millions out there, that then maybe you get a problem that you begin to wonder what's going on. But I think at that point, we're going to be seeing them less as something replacing my job, but as something that's helping me do my job better. Because everyone is going to understand how these bots work. They're going to be trained. They can be comfortably around them. And they begin to realize, hey, that means I can be more productive. I just got to have this robot crew that comes in here that works with me to do the stuff. It'll also make people's, eventually at that point, maybe it starts making it into the home. And when that happens, then people's home lives are a lot easier, because a lot of the things that have to get done around the house, they don't have to worry about so much, because now they have this robot butler, which is able to do this. So I see that it will, it's something that's not going to cause a major disruption to the labor market, which a lot of people fear that's going to happen. But it doesn't mean it can't happen at some point. And that's why we need to start having these discussions now to see what that's going to be like, to make sure that transition goes smoothly. So that's why I'm way more sanguine about the possibilities of how the labor markets will be disrupted, and not afraid that, suddenly there's going to be riots in the streets because everyone is without a job. The other thing to say is that, eventually the bots will be building the bots, which will allow them to do it. But at some point, whoever is controlling building the bots, they have to make a profit at the end of the day. And they're not going to build bots for the sake of building bots. The bots have to be somehow generating an income. They have to justify themselves. And if everyone's out of a job and can't afford to buy the stuff they're producing, they're not going to be producing these things. So there will be this natural equilibrium. And partly it won't be a very rough ride, because we're not talking about the bots scaling like that. We're talking about a more gentle one as they kind of come up, and eventually becoming more colleagues, more collegial, as opposed to competitors.